Okay, in this video we're going to talk about conduction, and that's charge transfer through contact. So you'll see in my picture I have a negatively charged rod, and I am going to use it to touch a neutral electroscope. Remember that in the negatively charged rod, it's negative because it has an excess of electrons. It has more electrons than it does protons, so it's net negative. And the electrons in the negative object are all repelling each other because there's excess, um, they're kind of like too close to each other, they're too concentrated, and they want to spread out. Um, and when they come in contact with the neutral electroscope, and it's neutral, remember, because there are equal numbers of protons and electrons, uh, the electrons have the opportunity to kind of repel each other and actually move and spread out. And because the electroscope is a conductor, it's made out of metal, the electrons can indeed flow from the negatively charged object into the electroscope. And they'll continue doing that until they've reached a sort of equilibrium. And that equilibrium is kind of more or less when the electrons are evenly spread out so that they're not being repelled any more in one place than the other. And then so the negatively charged object becomes a little bit less negative because it lost electrons, and the positively charged object, the neutral object, becomes negative because it's now gained electrons. And that's basically conduction. And it also works if you do the reverse. Say I have a positively charged rod, and I use it to touch a neutral electroscope. Well, instead of the electrons flowing into the electroscope, they'll flow out of the electroscope. Wow, this is really bad picture. Okay, so here's my neutral electroscope. And now if they touch, now the electrons will flow out of the electroscope and into the positively charged rod. So these arrows are confusing. So when this bottom arrow means I touch the two together, and then the electrons will flow from the electroscope to the positively charged thing. So now they're actually touching. There you go. And again, you'll get these leaves to repel. Because it now has less electrons than it does protons. And some of those electrons went into the positively charged rod. Now maybe I'll draw a couple of those in there or something. Right, so again, the rod is now a little bit less positive, and the electroscope is now positive. Because again, it has less electrons than protons. And then you should ask yourself, well, why do the electrons go from the neutral thing to the positive thing? It's like, well, the neutral thing it has too few electrons, right? It has more protons than electrons. So there's an attraction. It's positive. It's net positive. So it will attract electrons that are in the neutral object. And the attraction in the positive object is stronger than the attraction in the neutral object because the neutral object has more electrons that are balancing that out by repelling the electrons. So the electrons will naturally want to, quote unquote, want to go to the positive thing because there's a stronger attraction there. And just like when the negative thing touched the neutral thing, the electrons will keep flowing until they reach kind of an equilibrium where there's equal attraction in the positive thing, or in the rod and in the electroscope. And that's kind of, again, when the electrons will kind of spread out. And that is conduction.